Today, as we continue our study in right triangles, we're actually going to get into a study of mathematics called trigonometry. So we are going to talk about specifically the tangent ratio. So what is trigonometry? What is a trigonometric ratio? A trigonometric ratio is a ratio of the lengths of two sides in a right triangle. Now you can use trigonometric ratios to find the measure of a side or an acute angle in a right triangle. The specific ratio we're going to go over today is tangent. And for a given angle measure, the ratio of the lengths of the legs in a right triangle is constant, and we call that ratio the tangent ratio. So let triangle ABC be a right triangle with acute angle A. The tangent of angle A, which we would write in shortened form, tan A, but we would read it tangent of A, is defined as follows. It is the length of the leg opposite angle A divided by the length of the leg adjacent to angle A. So BC over AC, this refers to this diagram here. We have a triangle ABC. We're looking at angle A. We see that the leg highlighted in blue is adjacent to angle A, and the leg highlighted in green is opposite angle A. So tangent of A is equal to the green leg divided by the blue leg. So the leg that's opposite it divided by the leg that's adjacent to it. Let's take a look at example 1. Find tangent of S and tangent of R. Write each answer as a fraction and as a decimal rounded to 4 places. So tangent of S is going to be the side that's opposite angle S divided by the side that is adjacent to angle S. So if you look at angle S, you're just looking at the two legs, and the leg that is opposite angle S is RT, and the one adjacent to it is ST. Now RT is 80 and ST is 18, so 40 over 9. So it said to write each answer as a fraction, so 40 over 9, and also as a decimal rounded to 4 places, so that would be 4.4444. Now tangent of R, so now you're looking at angle R, and the leg that is opposite angle R is ST, and the leg that is adjacent to angle R is RT. You'll notice this is just tangent of S flipped. So that would be 18 over 80, which is 9 over 40, and that comes out to be 0.2250 as a decimal. Now let's use the tangent ratio to determine the length of a missing side. So here we have a right triangle, and we are given one of the acute angle measures, and we have the length of one of the legs. Now use tangent to find the length of x. How do you do that? Well, let's relate everything that we have there, including x. So 11 is the length of the leg that is opposite the 32-degree angle. X is the leg that is adjacent to the 32-degree angle. So remember that tangent of the angle measure, so tangent of 32, is equal to the opposite leg over the adjacent leg. In this case, that would be 11 over x. And then now we need to solve for x. So first I'm going to multiply both sides by x so I don't have x in the denominator. Then I'm going to divide both sides by tangent of 32 to get x by itself. Now 11 divided by tangent of 32, you're going to need to use a calculator to find this. Now in your calculator you want to make sure that you are in degree mode. By default, your calculator is in radian mode. Now to find this in your calculator, you will need to, depending on your calculator brand, but in general, if you have one of these Texas Instruments calculators, this will generally be the same. You'll want to go under Mode, which is the button next to the second button in the upper left corner. Click on Mode. And you can see if you scroll down, there's a row that says radian and degree. You want to make sure that degree is highlighted. And then you can go ahead and use the calculator now to find 11 over tangent of 32, or you can just find tangent of 32 and do this separately. So tangent of 32 comes out to be about 0.6249, so 11 divided by that is going to come out to be about 17.6. So the length of x is equal to 17.6. Okay, example 3. Find the height h of the lamppost to the nearest inch. Again, you want to look at the information that you have and see how you can relate all of it together. So we're still using the tangent of the acute angle, in this case that would be 70 degrees, which is equal to the opposite over the adjacent side. Now, the side that is opposite the 70-degree angle is h, that's the height that we're trying to find. And then the leg that is adjacent to the 70-degree angle is 40 inches. So this is equal to h over 40. Solving for h, we multiply both sides by 40, and that gives us 109.9. So it's about 110 inches tall. Our last example here. Use a special right triangle to find the tangent of a 60-degree angle. Now, because all 30, 60, 90 triangles are similar to each other, you can simplify your calculations by choosing one as the length of the shorter leg, and then you can use the theorem to come up with the other leg. So if we simplify this down, this is going to be the shorter leg is 1 and multiply it by root 3, so you end up with the longer leg being equal to root 3. So here's the picture of the triangle down here, and we see that the shorter leg is 1 and that the longer leg is root 3. Now, why did I choose 1? It was just a way of trying to simplify our calculation. If you chose 2, you know that the longer leg would be 2 root 3. This won't affect our tangent ratio because it is the ratio of those two numbers. So to find tangent of 60, this is equal to the opposite side over the adjacent side. So this is equal to root 3 over 1, which is simply root 3. Now if you had used, let's say, 2 for the length of the shorter leg, then the longer leg would be 2 root 3. When you find the tangent ratio, that would have ended up being 2 root 3 over 2, which would also simplify to root 3. So we know that for any 30, 60, 90 triangle, tangent of 60 degrees is going to equal the square root of 3.